about 30%. Well, I have a surprise for you. I guarantee that all of you have used natural language understanding today, perhaps without realizing it. This is something I put into Google when I came to Kuala Lumpur. Kuala Lumpur, what to see? What do you think happened next? Natural language understanding. So Google looked at the words that I put into the search engine. Kuala Lumpur, it realized that it's a location, and it put in information about Kuala Lumpur on the search results. And it also looked at the words what to see and interpreted that what it means are places to visit, must-dos, and listed even them in a row for me to go and see. So the old-style search engines would look at these words and actually throw them away, what to see. All of these are very frequently used words and usually treated like stop words. But modern search engines perform natural language understanding, but basically figuring out what is the search intention. So as consumers, we're used to this kind of technology, but I'm sure you're here today not as consumers, but because you want to use natural language understanding in your projects, or at least understand how you could do this. So in my presentation today, I will focus on practical applications. I will give you some examples, and I will also share with you some tools and tips that I've learned along the way. My introduction was so detailed, so I don't need to say much, but basically, originally, I wanted to do linguistics, but when I heard that you can actually use computers to understand language, I thought this is where the future is heading, and this is what I need to study. And I've been enjoying this. It's such a great field, and I encourage you to look into this seriously if you haven't yet. And my current company, Thematic, I use natural language understanding to help companies understand their customers. So what is natural language understanding? Let's define it a bit more formally. For some reason, when people hear natural language understanding, they always think speech analysis. You talk into your phone, and it understands you. But in reality, it's not about that. Speech first needs to be translated into text, and only then natural language understanding happens. Basically, it's about deriving meaning from text. And it's done by using a field of linguistics called semantics. So it's about the meaning and the modeling the meanings of words and phrases and sentences and documents and so on. You could view natural language understanding as a subfield of natural language processing, which is in turn is a sub-area of AI. And the reason why people say that is because some of the tasks, like text categorization or spell checking, can be performed quite accurately without modeling of the semantics behind it. But in reality, in my experience, things are a bit blurrier than that. Very often, the best text categorization algorithm will be using some way of representing the meanings of words and phrases. So, as a general framework, it's helpful, but we're heading towards the time where pretty much whenever we analyze language, we need to model the semantics. So how can actually computers understand language? Even people struggle when they keep misinterpreting things, using the wrong words, or misunderstanding each other. Well, it is very hard. It's a very non-trivial problem. And I want to explain what understanding means with some real examples. The first one is relation extraction. So basically, an algorithm would read a text and figure out what are some relations expressed in this text. Here are some examples of relations. So we have an entity, Kuala Lumpur, and the relations would be the fact that it's the capital of Malaysia, for example. These are called semantic relations. And by understanding these, by reading text, basically the semantic modeling happens. This is an example from an open information extraction system from the University of Washington. It's been developed for many, many years. And it's fascinating. Basically what happens is it reads unstructured web text, and then it uses syntax rules and frequency to extract structured relations, structured sequences. And in this way, they've extracted 500 million relations. Another example is a system called Probase, built by Microsoft, and they used patterns. Have a look at the sentence above. So, such as, if you see these two words connecting to other words, it indicates that there is some sort of relation between them. But sometimes it leads to errors. So what they've done is actually looked at distribution across all of the examples in their data and then added statistical likelihood of that particular relation between each pair of entities. They've also extracted millions and millions of relations. But how can you actually use it commercially? And this is the part that interests me most. So here are some examples, and the most popular right now is probably question answering. So it turns out if you want to build a question answering system very similar to IBM Watson, then you must first get semantic relations from text, because otherwise you wouldn't be able to answer user queries. But it's not just about extracting existing relations. Ideally, we want to extract new knowledge. And this is an example from a paper by Swanson where this process was actually done manually. So the author looked at the titles of PubMed publications and identified a causation that kind of follows through all of these relations between concepts. They found that lack of magnesium causes migraine. This is the holy grail of business intelligence. Imagine if we could give lots of text into a computer and it would figure out new knowledge and learn from it. The second example is sentiment analysis. I don't know if you guys know Brooklyn Nine-Nine, but I really like this show. And there's this guy who always has the same face, and it's virtually impossible to judge his emotions. So, in the simplest form, sentiment analysis is about figuring out is it a positive or a negative emotion. But I want to talk today about something that is a bit more complex. This is a company called Dick's Sporting Goods, and it's a huge retail store in the US. So it's a Fortune 500 company. It's massive, and it also has an online retail store. And Google has had them listed on their website, and they collected 10,500 reviews from people, and then they've organized them in this particular way. So you can see that Dick's Sporting Goods is doing pretty well. They have 4.4 out of 5, the satisfaction score. But the interesting part is shown below. So we're not just seeing positive or negative sentiment, we're also seeing what are the themes that people keep talking about in the reviews. So things like customer service or return policy. These are the ones with the most dread, and Dick's Sporting Goods needs to have a look at in order to improve their satisfaction score. And this is exactly what I'm currently working on at my company Thematic, where trying to pretty much help any company to get this kind of visualization and understand their customers. So we have sentiment analysis, which is not just about emotion, but also the themes. So which emotions described which themes. And it's not just about reviews. You probably have seen a form very similar to this one, where a company asks you for your feedback, very short survey. It's called Net Promoter Score. So you give them a score as a likelihood of whether you're likely to recommend them or not, and then you explain why you gave them the score. And a bank or an insurance or a supermarket would receive thousands of these comments per week, if not more, and it's a very practical application of sentiment analysis to basically figure out what are actually people saying and what do they need to work on. So the way we detect themes is bottom up. So we basically look at recurrent things and what are actually people saying. And once we've done this, the next step is your classical data science. You can basically apply many different algorithms and apply correlation or visualize the results. And it becomes a very valuable tool. So commercial application of sentiment analysis strategy. Basically, you can figure out where you should focus your resources in which particular area of your business. And of course, I must mention chatbots. This is a natural language understanding talk after all. Why are everybody wanting to build a chatbot? And to be honest, I have built one a couple of months ago as one of the consulting jobs for a US retail store. So chatbots are very popular because there is a stagnation in a different market, the app market. So lots of people made lots of money with apps, you could see, but you can see that now it's in stagnation. People don't download apps, and if they download them, they don't open them. And instead, they hang out in chats. Out of 5 most downloaded apps, 3, I think, are chat apps. It's just something that people like doing. They like chatting. And if you compare chats with apps, perhaps this is the worst possible example of a pizza app, and there are many more effective ways of ordering a pizza through an app, but it just feels more natural for us to use chat. And I experienced this myself. A few months ago, I had to buy a new washing machine. And normally, my husband and I would go into the store, and I know that you guys here in Southeast Asia love negotiating and bargaining and getting the best price. But it can be quite jarring if you are a bit introverted. So I was looking at the website, and then this chat window pops up. And I thought, oh, I could probably just ask for a price match here to this person. And it worked. I ordered the washing machine, and 2 days later it arrived. I didn't have to go and talk to somebody in person. Yes! But imagine if on the other side it wasn't a person. It would be a chatbot. So you can actually scale and sell to many more people in a more pleasant way and save money on customer service. Just a few words on the chatbot ecosystem. So in case you're not familiar with this, I found it helpful to separate it into 4 areas. One of them are the bots themselves, and they can be from complex ones to very simple. And the second one is natural language understanding. It's kind of a component, and not all chatbots actually need natural language understanding. Then you have the platforms where you develop them, and actually it's also optional. The chatbot that we developed was from scratch, basically a web service that, and we had to model very simple dialogue. And finally, the 4th component is the channel. This is where the bot would connect to the people. And ideally, you want to deploy across all of these channels so that you only build the chatbot once, but then it can talk through different channels to users. Here's something I put together as natural language understanding in current bots that we know, and in science fiction examples of our ideal understanding of a bot. And of course, we're so far away from the idea of being able to chat or talk to a computer on just about anything like Star Trek, or even build a relationship, have a friend or a lover, like in the movie Her or Knight Rider. In fact, many chatbots are not here to understand you, literally. They're here to figure out your intent and then help you to perform that particular action. Here's an example of what actually is happening. So you type something into a chat window, and then the first thing that happens is figuring out what is the intent. And this usually happens by running text categorization. A chatbot can recognize a limited number of intents, so this is the first step. Once the intent is known, there probably are some parameters that needs to be filled. If it's a flight, where is the flight to, on what date, and so on. Context is important. Sometimes you know things about the user, so you don't need to ask them again. And eventually, you have the command that you can execute. Some commercial applications of chatbots. Of course, customer service. The basic idea is that you provide information to the user with the least effort. And Macy's in the US have built a chatbot that helps you find the toilet. So you're in the store and you're lost and you need to go, and you just very quickly ask the chatbot, where's the toilet, and it kind of guides you. There are many more examples. Okay, now I want to share with you some tips. And the first one is not one tip, but really a conversation about when is it a great idea to buy a commercial solution, and when is it better to just build your own using open source. And in my work, I've spent time doing both, selling something that I've developed as a product, but also helping companies building their own solutions. This is what I've learned. So the first one is about the fact that you shouldn't be paying money for algorithms. There are plenty of algorithms out there that are excellent, and when you're paying money, it needs to be for a solution for a specific problem. You shouldn't need people to basically customize something that isn't solving the problem end to end. So in my opinion, this is the second point, the vendor should provide all of the support, and you shouldn't need any expertise in order to use a solution. If you have access to in-house, to people in-house that can help you understand the problem that you're facing, and which tools are best for it, or you can perhaps attract consultants, then building open source is a good idea. The third point is interesting, and it's specific to natural language understanding. So a lot of open source that is out there right now has been actually built by academics. And academic researchers only have access to text that is freely available. For example, Wikipedia text, or newspaper articles, or social media like Twitter. But in reality, businesses actually often don't need analyzing that kind of text, and instead they need making sense of emails or customer feedback. And it turns out all the open source solution would break on this text because the nature of language is important. The fourth point is about the IP. The part that you're solving, is this something that many companies need? And if so, what kind of advantage would you have by building it in-house? In that case, I would just buy something ready to use. But if it gives you competitive advantage, for example, one of my customers used a group of people to do a very manual and tedious and boring task, reading web pages and identifying information from it. So when I started solving it using machine learning and NLP, they told me that I'm not allowed to tell anybody about the fact that I'm working with them. It's kind of their secret sauce. And then it's a good idea to do it in-house end-to-end. Let's talk a bit about libraries. So I find it mind-boggling that today you can go and download some of the same libraries that companies like Google used to solve the AlphaGo challenge, or even used in some amazing applications. I've listed some of them. The one that recently became popular under the natural language understanding column is Spacey. So they have an interesting idea. So it's a library that you install for solving certain natural language understanding tasks, but you don't need to worry about algorithms. They always update to whichever algorithm produces the best results based on academic publications. But which library should you use in general? I think you need to choose one based on your existing workflow. So one with the best support and that fits to your development team's expertise. But in general, I think they're roughly the same. In terms of the algorithm here, even now, I always try them out on whatever data I'm working on at that particular point in time. I would just test them and see what the results look like. And many of them will make it very easy for you to see. And this is scikit-learn, which basically shows you how data can be separated in different ways by different algorithms. The second tip is the fact that domain knowledge is significantly more important than the best algorithm. Think about it. Do you want to solve the right problem with a simple solution, or do you want to solve the wrong problem with the fancy algorithm? Here's an example. Imagine you want to build an app that has a natural language interface into Salesforce. So for salespeople, it's always very tedious to create reports showing how many deals they've closed, and there is a lot of variety of how you can configure these, so it's quite complicated. So these two guys decided to do this, and one of them was actually working at Salesforce. So first of all, he knew that there is this problem. Second, he spent a lot of time talking to salespeople, understanding what are the possible questions they would even be asking, so that they're not modeling for some other questions that wouldn't be relevant. And then also they knew how Salesforce works and how to connect into it. So they ended up winning $1 million, started a company, and then they got acquired, I think, a year later. So it's important to understand what is it you're actually trying to solve. The third tip is about language model. And this is similar to my point about academic libraries that were developed on texts that have no relevance to the business. The cool thing about language models is a lot of them can be created without needing annotated data. So all you need to supply is raw text. So instead of using a language model created on Wikipedia, for example, I think it's a much better idea to think about what kind of text is available in your business, and then collect it, and then build a model from that text. And that's because language is, because of the semantics, basically. A word like bloody in the context of a hospital means something very specific, whereas on social media, it has a different meaning. Some of the examples of where you can get text. For one of the projects, it was for a software DJ company. What we needed to do is basically build a solution to understand customer feedback, and they only had 1,000 responses per month, so very little data. So what we did is we went and found that they have a forum with millions of posts, and we crawled that forum, created a language model, and then used it, and that worked pretty well. So when I say language modeling, I mean word embeddings. This is the modern way of doing natural language understanding on text, and a library like Word2Vec or its variations are actually extremely powerful, and they can work already with relatively small data sets. That surprised me. So depending on how much variety is in your text, you can find similar words by only feeding 1,000 sentences into it. So word embeddings on its own is just about word similarity, but how can you actually use it to solve business problems? Here are some examples, and I want to go in a bit more detail into one of them. So Stitch Fix is a company in the US, and what they do is provide you with a stylist. And that stylist sends you once a month or once every 2 months a completely put together outfit. So you don't need to shop. I know you guys love shopping, but this is actually a really cool service, I thought. So on Amazon, there's a huge database of things that you bought in the past, and other people who bought this also bought this, so you can use all this data for recommending a new item. But when a stylist is working with a client, they don't have any information about the client other than where they live and whatever they said in chat. So when a woman, for example, says, "I'm pregnant," Stitch Fix uses a word-to-vec model to find recommendations based on product descriptions. And the word pregnant will never appear in a product description because correct word is maternity. So this is how you can make the link and help stylists to do their work efficiently. My fourth tip is about deep learning, and natural language understanding actually isn't the answer, or isn't always the answer. When a lot of people, when they say deep learning, they think that it's deep understanding, but it's not. It's really about optimization. It's about getting the last 10% out of your accuracy. And often, very simple techniques work, and this is not specifically for natural language understanding, more for data science, but Monica Rogati is quite a famous data scientist in the US, and she says her favorite algorithm is division. And you can do a lot with this. Everybody can do division. Basically, what deep learning is very good at is figuring out how to divide up data that's distributed in a weird way. But a lot of the time, this is what I see with my clients, very simple thing like naive Bayes, and this is what Sean was saying in his talk as well. A lot of the time, it's about putting a bit more data into the algorithm rather than modeling the problem using something complex. I found this funny image. I'm sure people appreciate this. But basically, the point is that at the end of the day, a lot of us don't need to understand how all these algorithms work. It's just about importing another library into your workspace. Deep learning does have really important application in natural language understanding and in business. And as a rule of thumb, is whenever you generate new language, this is where, without deep learning, you won't get as good results. So machine translation, absolutely, and also abstractive summarization. So when you have a computer reading a text, for example, a report from a radiologist, and they needed to create a short summary, and new text is generated, this means abstractive. This is where traditional techniques will produce very poor results, and only deep learning can actually help you produce something meaningful. Here are the tips again. So remember that your domain knowledge is the most critical thing, and keep it simple, basically. And get creative whenever you need to analyze language from your organization. People always ask me, what is the future of natural language understanding? Hoping I will make some predictions. But really, it's actually really hard. So I'll tell you a story from my PhD supervisor. He wrote a very famous book called Managing Gigabytes, and he wrote it in 1993. In the preface, he said, and his co-author, they said, the next edition will have to be renamed, surely, to Managing Terabytes. 1999 came, everybody's still dealing with gigabytes. So they had to apologize in their preface for the second edition and saying, no, we were too harsh, and so much for technology prediction. So without making any huge prediction, I think that you should absolutely get into natural language understanding. It's going to be only mature. How quickly, we don't know, but it's getting more and more exciting to work in this field. This is what I found. Here's some resources that I think you might find helpful. If you like chatbots, I highly recommend the O'Reilly Bot podcast. I've listened to pretty much all their episodes, and they're awesome. The last one is actually about natural language understanding, specifically. Then the second resource is really interesting. So this is academic papers where they don't just release the paper, but also the code and the data. So if your business problem is very similar to what paper describes, you can actually get far ahead very quickly. And otherwise, the last 3 points are tutorials, that are very useful to get started with natural language understanding using deep learning or using other techniques. And you can always find me on Twitter. I try to share these kinds of things. And on LinkedIn, I publish blog posts more on the business side, how to apply it and how to make natural language understanding useful for different business applications. I hope you learned something new, and I'm happy to take any questions.
Dr. Medelyan, Philip Lester from Petronas. Thank you very much for a fascinating talk. I have two questions actually. The first one is in the tips that you gave, you didn't mention ontologies. Would that be the same as word embedding?
No, ontologies is very different. So ontologies are usually modeled by people and not always explicitly. For example, Wikipedia can be a source for an implicitly built ontology. And ontologies have a very important place in natural language understanding, absolutely.
Okay, thanks. My second question was the example you gave about the purchase of the washing machine.
Yeah.
How can you tell that the chat agent that you communicated with is actually not a chatbot? The reason I ask is because I like to use those kind of agents as well, and there are some times when the responses get a bit funny. So I'd like your opinion on that.
Well, actually, it's a good question. So how do you know when you're using a chat application that the person behind is a person or a chatbot? It's actually good practice when you're designing a chatbot to actually be explicit about this to the user so that they know that it's not a person. And then always give the user an option to contact a person, to be forwarded to a person. So if you're chatting to somebody and they don't make sense, it's not your fault, it's their fault. They didn't design their system properly.
Okay, so what you're saying is that you can't, if through the interaction, you can't really tell if there's a person behind or whether it's just a chatbot.
Well, you can tell by seeing weird answers.
Okay. Thank you.
This is Ian from RHB. Can you actually apply NLU in a multilingual society? Say, for example, because in Malaysia we mix text together along with other languages.
Yes.
How do you train an NLU on that?
Very good question. So how do you apply natural language understanding in a case where text comes in a variety of languages? I've never actually tried using NLU on Southeast Asian use cases, but I did work on a project where a large telecommunication company received feedback from 7 different European countries. So the language ranged from Russian to Armenian to Belgian. And at the end of the day, the person receiving the results of the analysis was an English-speaking person. And so what we did, we actually translated everything using Google Translate first into English, and then created a language model across the entire text, including incorrect translation. And language model actually can capture translation errors correctly, similarly to how they can capture misspellings. So that was our solution. But I would be more confident about recommending it if I actually tried it on Asian languages.
Okay, sorry, I still have another question on the chatbot and this sentiment analysis. So if ever someone actually put in junk information or junk questions in the chatbot, are you able to filter it out for especially for the sentiment analysis?
So how do you mean how chatbot should be handling junk?
Yes.
So basically the best thing to do is to just ignore it, not to try to deal with any type of weird content in a smart way. Just say, sorry, I did not understand you. Here are the things you can ask me. Here are the things I can help you with. interesting thing I wanted to share with you is rude words. It's incredible. People who build chatbots complain that pretty much all of them get sexually assaulted. And the recommendation is, when this happens, is to actually tell the user that it's not okay and offer them to apologize. If the person doesn't apologize, they get kicked out of or cannot interact with chatbots for 10 minutes. Kind of like what you do with children. Put them on a naughty chair.
Thank you.
Okay.
Okay, guys, maybe 2 more questions because we are trying to keep to the time. Doctor will be here all day, right?
Yes.
Yeah, so...
Yeah, I got a question here.
Okay.
Can you hear me? All right. My name is Jinfa. Just like we were talking about semantics just now, but you didn't touch on the topic of RDF, Resource Description Framework, right? In terms of semantics and machine language learning and so on. Just like to see your views on that.
My view is that it's essential for certain applications. In particularly, it relates to the comment about ontologies. Ontologies are usually modeled using RDF, and when you extract relations from text, you also have the option of encoding them using RDF, and this makes it easier to then build a question answering system to query that knowledge.
Hello. Yep. I have a question, especially on the sentiment analysis. You're talking about the domains, right? We have a lot of domains, telcos, whatever. But there is one very specific domain that I think it's quite interesting when you want to try to do the sentiment analysis, which is political domain, politics. So in politics, when you try to analyze the Twitter, Facebook, or all the social medias, nowadays the politicians, they use the bots. So when you try to do sentiment analysis, sometimes you can find a comment, natural comments, which is people giving their opinion, voice out their opinion, but also there are bots, like an army of bots that just post things. And so how do you try to identify and, this is really people, this is just, some paid things or bot? And thank you.
I think it's related to spam detection. So spam in the context of social media, all of these bots are not the kind of bots I was talking about, but more malicious way of disrupting the conversation or just shoving irrelevant things into people's faces. And I think that's the first task, is basically separating the noise from the signal, from what you actually need to analyze. So if you're in that kind of situation, this needs to be part of the data preparation analysis, data preparation step.